Julia is a high-performance and dynamic programming language. It is also general purpose and can be used to develop any application. It is said to be very fast like C. We will learn about functions, modules. We will even touch on developing web servers with Julia. We will connect with MySQL, and at the end, learn how to plot graphs with Julia. Let us begin learning Julia. After downloading Julia for Windows, install it. Take note of the installation part while you are installing, because you will need to specify that part later on. So give it some time to install. After installation, they might ask you, do you want to run Julia? Yeah, you can just say run just to confirm. And boom, we have Julia running. Quite beautiful. But currently, we don't have Julia in the system part. For example, if I type Julia, it isn't recognized. So we go to where our Julia was installed. Mine was local user, my name, then app data. App data was actually hidden. I had to show hidden files. Now go to System and Security, go to System, Environmental Variables. We want to add this part to System Variables. Currently, Julia should be in the System part, so when I type Julia, I see the beautiful Julia printout. The next thing is to install IntelliJ. Now, in IntelliJ, we're going to install the Julia plugin. So we go to Plugins, and search for Julia. If you can't find Julia there, then you can Google the plugin and click on Get. And from there, you can try to install it. When I open my IntelliJ, it shows me the Julia plugin to be installed. I can click on OK. After restarting, we can create a new project. We can choose Julia. We need to specify the path to the Julia bin. Remember the path when we were installing Julia. So, in my system, I still needed to view hidden files to find the app data. So I find the path to bin, you can see the Julia exe. So that is the path to the executable. We move on. We can give our project a simple name. I will call it Learn Julia. And we have a new project ready. You can see our source folder. You can right click, create new Julia file. Give this Julia file a name. And we print our first output and write our first Julia program. This is awesome. Then we run. and it ran. That's it for Windows. After installing Julia, we need to add it to path. So we say sudo nano etc paths. We put our password and you can see the paths here. I have already added Julia, as you can see right here. To get the path of Julia, go to Applications. You will see Julia. So right click and say Show Package Content. Go to Content, go to Resources, go to Julia, go to Bin, and you can see the Julia executable there. We would use this path when we are creating a new Julia project in IntelliJ. I already have the Julia plugin installed here, and you can see the path to the Julia executable here as well. So this is for Mac. I have shown you for Windows. You're ready to program in Julia. IntelliJ isn't the only IDE, but this is the steps if you want to use IntelliJ. If you want to use other IDEs, you are free to use them. If you have been programming in Python or even Java before, you might have been using one of JetBrains' products called IntelliJ or even PyCharm. However, when you come to Julia world, we have Juno. Now, I will be using IntelliJ for the beginning of this tutorial. At the end, I'll come back to Juno. You can go and download and install Atom. After that, you then install the Juno package. In Mac environments, you might be given a zip. You unzip it, and then you will see the application file. You can drag and drop that application file to where you have your applications. We can now open Atom. The same thing applies for Windows. You download it and follow the instruction for installation. Now, after installing Atom, whether be it Mac or Windows, you have to install Juno package. You click on Command and plus or Control and plus to open this settings window. Go to Install and search for Uber Juno. The name of the package we want to install is called Uber Juno. It will search for it, and then when it pops out, you install it. Currently, I have already installed it, but for you, it will install and then install some packages. You give it some time. After the packages are installed, you're ready to rumble. You can open a folder, create a Julia file there, and open the Julia file inside here. You could create a new folder and create a new file in the folder. The file extension for Julia files is JL. So in case you have any Julia file that you want, you could open it or create a new one. Let's test some code. We write it and then we click run. Because this is my first time of running, it is doing some setting up. After everything is ready to go, let me try it one more time. And we run it. We run it again. Let us test a for loop. I haven't taught you for loop yet. We're just testing Juno. In case the text is too small, you can increase the font size by Ctrl Shift and equals, or you go to your menu and search for increase font size. I will increase mine manually here. So that's it. You can follow along using Juno or IntelliJ, but in the ending portion of this course, we will come to Juno when we want to plot graphs. Julia, unlike some languages, has variable type inference. So I don't need to state the type of a variable. It will be inferred automatically. For example, I can say num is equal to 5. If you notice, IntelliJ is giving us a hint that this is of type int 64. We will talk about variable types later, but in simple terms, just know that Julia knows this is an int. When we print the num, it will print out 5. As expected, of course. What else will it print? But because it is a num, we can perform some arithmetic operations. Also, we can reassign num to a new value. It was formerly 5. Now it has a value 1. We can even assign it to a different data type. Now, num is a string. Notice that IntelliJ is giving us a hint. Hey, this is a string. Unlike some languages like, let's say Java, where you can't really change the data type of a variable by assigning it to a new type, you can do that here. Julia is also case sensitive. So if I create a variable num, it's the same spelling, but the first letter is capitalized. Julia sees that as a different variable from the name num with small letters. You can see when I say num with capital, it prints out 57. If I say with small letter, it prints out hello. You can't use keywords as variable names like else, if, and some other keywords. You can't use them as variable names. You should expect that, shouldn't you? You can use underscores in name. For example, I can have a variable called the name, and I can put an underscore between the and name. Julia, since it is present for, scientific calculations and even data science, we have some constants like pi. Pi here represents the mathematical constant pi. If I say pi times 1, you can say 3.14 blah 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 blah. Approximately 3.142. However, I can actually create a variable named pi and give it a value 90. If I do this and I say print pi times 1, what do you think is going to happen? It will actually print 90, because anytime I call pi now, I am talking about the pi I created and no longer the constant present in Julia. But there's a tricky thing about this. If I put pi is equal to 90 after calling print pi times 1, I will have an error. Why? Because when I say print pi times 1, I am saying I want to use the constant pi. So that means in this program, pi means the constant. There wasn't any variable before now called pi. I can't change the value of a constant. So it tells me, boy, that is an error. If you want to print in the next line, you use print line. If I say print, it is going to print these two outputs in the same line. But if after the first line, I want to go to the next line in the console, when I'm printing pi times 1, I should use print ln. I normally call it print line. When you use print ln, after printing that output, it moves to the next line to print the next output. So this is a short overview of Julia variables. We still have a lot more to cover in Julia variables. For now, go and play with what we have learned. In this lesson, we're going to look at Julia integers and floats. We have different integer types in Julia. As you can see in this table, from int 8 down to uint 1 to 8. We also have a bool type. When you see int and uint is for unsigned integers. And the difference between these types are the amount of data they can hold. So we have int 8, int 16, int 32, int 64, and int 1 to 8. We also have floating point types. Float 16, float 32, float 64. All having different precision. Float 16, half precision. Float 32, single. Float 64, double precision. By default, if your system is 64-bit, your int values will be int 64. If they are 32 bits, they will be int 32. Let us go to the code and check out what I just said. We can check your system bits from Julia by using the system word size. So I would print out sys.word size. My system is a 64-bit system, so we see 64 printed out. If we create an int, by default, the int will be int 64. And we can verify that this variable is int 64 by using the type of method. So we type of and pass in the variable. It will return the type of that variable. We see int 64 printed out. Now, let's say I actually want to create an int of int 32. I will pass in the number into a bracket and call int 32. So this will manually create a variable of type int 32. That is why when we call type of, we see int 32 printed out. There is a type called int. It doesn't have any number after it. This is like a symbol to represent the default int type for that system. If your system is 64 bits, it will create a variable of type int 64. If your system is 32 bits, then this symbol int will return a number of type 32. We also have float. By default on my system, you can see that it is float 64. And I have a value 0.5, which is going to print out 0.5. We can also use E notation. You can assign a number with E notation to a variable and so on. Just like in the case of int, I can specify that I want float 32. You can verify using the type of. So let us check the type of this variable score. We'll write type of, and then pass in score. We should see float 32 printed out. Now for some high precision, arbitrary precision, you can use what we call big float. It's a special type. So if you print out 2.435, you can see the printout statement. We have some real deep precision right there. You can read more about big floats in the documentation. We also have big ints, which is the int brother of big floats. So these have high capacity for some needed precision. These are the data types we can use in Julia to work with numbers. Depending on your use case, you can choose the type you need or just use the default type for your system. Sometimes you might want to convert a particular type of variable, for example, int64, to another type like float64. We can use the convert method. The convert method, on the left, you specify the type you're converting the variable to, and on the right, you specify the variable you want to convert. So I am converting the variable num into a variable of type float64. It is saved in the variable called fnum. Now, if I print out fnum, you can see it printed out 70.0. So showing that it is a float. Now, just like in other languages, we have the comparison symbols in Julia. I can test for equality using the double equal to sign. This is saying num1 is equal to num2. It is false. So it will print out false. Now, if I say num is equal to num3, they have the same values, so it is true. I can say num1 greater than num3. Nope, that is false because they actually are the same. So none is greater than the other. If I say num2 greater than num3, it is true because num2 is 78, num3 is 70. I can use the test for inequality. I can say num2 is not equal to num3, which is actually true. I can use greater or equal to. This tests if the first variable is greater or equal to the second variable. For this case, it is true. Even for the case of num and num3, num isn't greater than num3, but is equal to it. So that satisfies this comparison. You could even chain comparisons. This isn't possible in all languages, but it is possible in Julia. Let us do some chaining right here, right now. Now what this says is num1 is greater or equal to num3. Num3 is equal to num. Num is less than num2, and num2 is greater than num3. If all these are true, you are going to print out true. If anything was false, then the whole expression is false. Let us tamper with this and make one of the expressions false. For example, and we run it again, and we see false is printed out. These are quick overviews of comparison and conversion in Julia. You can go to the Julia documentation for more in-depth examples and possible operations you can perform. Sometimes you might need to round up numbers. For example, I have a number here, 3.719, and I want to round it to the nearest whole number. I can use the round method. Make this number round. So if you remember your maths, this will round it to 4.0. So that is how we use round, as simple as that. Now, if num was like 3.1, the nearest whole number will be what? 3. If you notice, the return type is still a float. As you can see, based on the decimal place put in, if you want it to round it to an int, I can specify it in the round method. I will put it as the first argument. So I am going to say int64, num. Now, if num was negative, for example, minus 3.8, the nearest whole number is minus 4. If it was minus 3.1, the nearest whole number is minus 3. So round is simply saying, where is the nearest whole number? We have another method called floor. Just as the name sounds, to the floor, you're rounding down this number. So round a method down. To round down 4.3, it will be 4. To round down 4.91 will still be 4. So rounding down is rounding it to like the next lower whole number. So even if it is 4.99, if you want to round it down, it's going to be rounded down to 4. Now, with negative numbers, it might be a little bit tricky. For minus 4.31, rounding it down will give us minus 5. Even if it's minus 4.91, rounding it down is minus 5 because minus 5 is smaller than minus 4. That is the nearest smallest number after that minus 4. We have ceil, or I like to call it for the ceiling. This is rounding it up. So round up 4.91 is 5.0. Even if it was 4.01 and we want to round it up, it will still give us 5.0. So you have round in general, you have floor, which rounds it down, you have ceil, which rounds it up. But there is one tricky guy called trunk. It behaves like ceil and floor, depending on the sign of the number. So trunk tries to round the number towards 0. Let's give an example. We have a number here, 4.01. If I run trunk on it, it rounds it to 4.0. Even if it was 4.91, it will round it to 4.0 because 4 is the nearest number to 0, or the nearest whole number to 0 after 4.91. If the number was 4 minus 4.91, what is the nearest whole number that is closer to 0? It's actually minus 4. So if we run trunk on minus 4.91, it rounds it towards 0. So the nearest whole number to 0 after this is minus 4. Even if it was minus 4.99 and we run trunk on it, it will return minus 4.0. So when the number is negative, trunk acts like ceil. But when the number is positive, trunk acts like floor. So that is what we can use. You have different options depending on how you want your number rounded. Of course, just like in the case of round, I can specify that I want the return type to be of type int64 and not a float. We have some division functions. If we don't use any function and we perform a normal division like this, we would have a normal answer like a float. We have a method called div. What div does is it will divide but then truncate the answer of the division towards 0. So truncate 1.6 towards 0 gives us 1. We have CLD. CLD will divide but then perform a ceiling division. So if you ceil 1.6, you get 2. We also have FLD that will floor the division. You can guess the answer by now. When we divide it and we get 1.6, if you floor 1.6, you get 1. So kind of similar to truncating. We have another function called rem, which will return the remainder of the division. REM. So if you divide 5 by 3, the remainder is 2. Let us run it. We have another method called mod, which returns the modulus. Noun. When we are dealing with positive numbers, rem and mod tend to give the same answers. But when you introduce negative values, it tends to differ. Look at the formula for mod. And below, I wrote the documentation definition of what mod does. Generally, when the numbers are positive, they give similar values, but their actual formula is different, and the difference is displayed when we start dealing with negative numbers. You can check the documentation and read more about mod and rem. We have GCD. What GCD returns is the greatest positive common divisor of the numbers you give it. So I could give it 3 numbers or more, and it will return the greatest common divisor. We could try another number or another set of numbers, and we get the greatest common divisor, which is 12. We also have LCM, which is the least common multiple of the numbers. The least common multiple of these numbers is 42. So here are the common division functions in Julia. You can read more about them in the documentation. Play with them to see how they respond depending on the input you give them. Let us talk on some mathematical functions. The first we will treat is ABS. ABS returns the absolute value of a particular value. So let us call that value X. ABS will return a positive value with the magnitude of X. So if X is minus 5, it will return 5. If X is minus 8, it will return 8. So it returns just the magnitude and a positive value, ignoring if it is a negative value. We have ABS2. What this does is it returns the squared magnitude of the value you give it. So if I put in 8, it will return 64. If I put in 5, it will return 25. We have another function called sign. It indicates whether what you pass in is positive or negative. If it is positive, it will return 1. If it is negative, it will return -1. If you give it 0, it will return 0. So you can use this to check if a number is positive or negative. This is a cool tool. Another version is called sign bit. Now, the sign bit checks if the sign bit is on. For example, for number 5, this number, the sign bit is off, so it will return false. If I put -5, the sign bit is on. So it will return true. We have another one called copy sign. Now, copy sign takes two numbers. Let's call it X and Y. Copy sign will return a value with the magnitude of X and the sign of Y. In this example, the magnitude of X is 5. The sign of Y is plus. So it will return a positive value of 5. Did you get that? Okay, let us switch the values. Let us make the first value 4 and the second one -5. It will return a value with the magnitude of X, which is 4, and the sign of Y, which is minus. So we would get -4. That is what copy sign does. We have flip sign. What flip sign does is a little bit different from copy sign. It returns a value with the magnitude of X, but the sign of X times Y. Assuming we make it value and value too. So the magnitude of X is 5 and the sign of X times Y is minus. So we would get -5. Now we have other functions like square root. To calculate the square root of a number, you write square root. That's how I pronounce it. Square root. So you find the square root, passing the number, you get back the square root as a floating point number. Let's say you want to go higher, you want the cube root, you can get the cube root as well. There are many other functions that I will not cover here. For example, you can have log. You can calculate the log of a number, and there is even a function to calculate the hypotenuse of a triangle. You give it the other two sides and it returns the hypotenuse. You can go and check the documentation for more mathematical functions you can perform in Julia. In Julia, we can deal with complex numbers. If you remember in your maths class, how we dealt with complex numbers, when you have the symbol I, but in Julia, I wasn't used, so we have IM used when we're creating complex numbers. We can print out this complex number and then it will be printed out in the format of complex numbers. We can also perform mathematical operations on this. For example, I can say print out 2 times value. 2 times value should give me 2 plus 4im, as you can see in the output. So this is quite beautiful for, scientists that want to deal with complex numbers. Assuming you want to extract the real number from a complex number, you can use the function real. So I'll pass in the complex number and this will return the real number. In this complex number expression, the real number there is 1. To get the imaginary number, I would use the function imag, mag. I am going to use imag. The imaginary number there is 2. I could even say imag 2 times value. So if I multiply the complex number times 2 and I try to get the imaginary number, at that time, the imaginary number will be 4. So it returned 4. So you can go and check more about complex numbers. Now, we can perform normal division in Julia. For example, 7 over 3. We have 2.33 blah blah blah. Sometimes you want to just have a ratio representation, like a rational number. For that, use this symbol, the double division sign. It will preserve the rational representation of this division. So when I print num, it prints out 7 over 3. So it doesn't give me the floating point representation, it gives me the fractional representation of this variable. I could even perform mathematical operations on it. For example, if I say 2num, it gives me 14 over 3. Let's say in future I want the floating point representation. I could say float and then pass in the rational number into it, and it will give me the floating point for that rational number. Let's say I just want the numerator. The numerator here is 14. So it prints out 14. What if I want the denominator? Of course, you can guess. I will just call denominator. So it depends on what you are doing. Sometimes you don't want floating points. You just want the rational number representation. Now, if you give or you create a rational number and they have common factors, they will be reduced. For example, 21 over 6 will be reduced to 7 over 2. When I print out num, I will see 7 over 2 because they had common factors and Julia reduced it. I could even have like 10 over 50. It will reduce it to 1 over 5. Now, because they are rational numbers, doesn't stop me from performing comparisons. For example, 10 over 20, which is 1 over 2, I can say, is this equal to 0.5? It is. So when I print out the answer, I see true. So this is quite beautiful and allows you to perform mathematical operations and use what is convenient for you depending on what you're solving. In Julia, we have cars. Now, I don't mean automobile, I mean characters. A car value represents a single character. Now, this value can be converted to a Unicode, and we can convert a Unicode to a car. For now, let us just print out this character in simple terms. If you notice, a character is surrounded by single quotation. That is to specify that this is a car. Now look at the ASCII table and the corresponding ASCII code. When you convert a car to its corresponding code, you can use this table to verify and know what you're converting. We can convert a code to a character. For example, if we say convert 100 to car, we're going to get D. We can also convert a character to its corresponding ASCII code. We would use the int function. So we would call int and pass in the character we want to convert. This should give us 100. We can even perform comparisons between characters, a limited number of mathematical operations, but at least we can perform some. So for example, let us compare X and D. X has a code of 120 and D has a code of 100. So that means X is greater than D. If we check x greater than d, what do you think we will get? We would get true. We can even perform a minus. We can say x minus d. X is 120, d is 100. X minus d is 20. If I say a plus 1, of course, we get b. If I say a plus 5, f. So these are the foundations of Char in Julia and the little mathematical operations we can perform using them. Just like in other programming languages, to create a string in Julia, we use the double quote. And with that, we have a string created. Now, there are some limitations. For example, if I try to add a quoted string within this string, it will give an error unless I escape it with a backslash. So let's say I want to print Julia is awesome, but awesome within a quote. I will have to escape those quotes to tell Julia that, hey, print out this quote. It is not the beginning or the end of this string. However, to make this simpler, we could use the triple quote version of Julia string. Now, the triple quote version enables us perform some special behavior, and we can use it to create longer blocks of text in Julia. We can have multi-line with triple quotes and maintain particular indentation. It all depends on your use case. Sometimes you might need just the double quotes. Other times you might want to use the behavior of triple quotes. Just like in other programming languages, to create a string in Julia, we use the double quote. And with that, we have a string created. Now, there are some limitations. For example, if I try to add a quoted string within this string, it will give an error unless I escape it with a backslash. So let's say I want to print Julia is awesome, but awesome within a quote. I will have to escape those quotes to tell Julia that, hey, print out this quote. It is not the beginning or the end of this string. However, to make this simpler, we could use the triple quote version of Julia string. Now, the triple quote version enables us perform some special behavior, and we can use it to create longer blocks of text in Julia. We can have multi-line with triple quotes and maintain particular indentation. It all depends on your use case. Sometimes you might need just the double quotes. Other times you might want to use the behavior of triple quotes. You can extract a character from a string by specifying an index. Remember that in Julia, index starts from 1. So index 1 in this string is J. And then we move on. Index 2 is U, index 3 is L. So if I say letter is equal to word, index 1, letter is a char that has the value J. Simple. So when you see a string and you want to extract a particular character, all you need to do is call the string and specify the index. It will extract the character in that particular index. Let us say we want the character in index 5. That is A. We can also extract a string by using an index range. So this is saying give me the string from index 1 to 5. And that is Julia, because J starts from 1 and the last character A is in index 5. We could say give me 7 to 8. That is the string is. Now, you have to be careful not to give it a range that is out of bounds. For example, if I say give me the string in 7 to 80, we don't have any string here with index 80, so we get an error. You can see it's a bounds error. So have fun, but be within bounds. There are different ways to concatenate strings in Julia. So I have 3 variables here, word 1, word 2, and word 3. I could use the string function. I pass in the strings I want to concatenate, separated with a comma. It returns a string that has all the strings concatenated. Now, this is one method. Another method is to use the star symbol. And this might seem a little bit weird because commonly in programming, many languages use the plus symbol to concatenate. Julia is using this multiplication symbol. So here is the reason from the docs. You could read that it had to do with things being commutative and non-commutative. Now, we also have string interpolation. Let's say I have a variable called experience and another called word. We could do string interpolation using the dollar symbol. This will result in a string that says Julia is fast because the variable experience represents fast. We could change the value of experience and it reflects in the word string. Now it says Julia is cool. I could say easy and it will say Julia is easy. I could even change the value of experience to a number like 100 and it will say Julia is 100. Now this is a simple expression, but we could even perform mathematical expressions. For example, we can multiply experience times 2. So when we print this out, it will say Julia is 200. So we have all these tools depending on the one that is suitable for you. In Julia, there are different ways to test for equality. We are going to look at the different ways. The common way, of course, is to use the double equal to sign to test for equality. So this simply tests is A equal to B. Another way to test is to use the IsEqual function. Now, this generally behaves the same way as the double equals to sign. There is a subtle difference between IsEqual and the double equal to sign. For normal positive values, they behave the same, but they behave differently for floating point numbers. They treat -0 and +0 differently. For IsEqual, it sees minus 0.0 and plus 0 as different. But the double equals to sign sees them as the same. There isn't any right or wrong way of handling it. The only difference is you could use IsEqual when you are sorting a group of numbers. Now, for example, generally, if I have 5.0 and 5, the double equal to sign will tell me true. I could also use IsEqual to test them. I should expect true as well. However, there is a third way, triple equal to sign, and I see false. What is this all about? Now, triple equal to sign is strict in the sense that it tries to test if the first is identical to the second. That means there is no difference. So 5.0 is mathematically kind of the same as 5, but they are not the same. 5.0 is 5.0, a floating point. 5 is a whole int. So if you use the triple equal to sign, they are not the same. The same thing goes for rational numbers. 1/2 is the same as 0.5. But if I use the triple equal to sign, it sees them as different because they are of different representation. Mathematically, they are similar, but they are not identical. Only if I have something like this, 0.5 and 0.5, before the triple equal to sign will give me true. So it all depends on what you are doing. Sometimes you might want to use the double equal to sign. That is fine. Sometimes you want to sort numbers and you have -0 and positive floating point. You could use the IsEqual function. Other times you want strict comparison. You could use the triple equal to sign. We are going to look at the find operations in Julia. You might notice that my voice is a little bit different. Don't worry, I am just using a different mic. It's still me. So now we'll call the find first function. The find first function has different methods, but we are going to use the one that collects a predicate and a value. Now, it will return the index or the key of the first element of the value for which the predicate returns true. So in simple terms, it will return the index of the first occurrence of the character A. That is 5. So the first character A, we have different A's in this string, but the first A has an index 5. So that is why it returned 5. We also have another function called find last. This will return the last occurrence. The last A has an index of 10. So we can use find first or find last. What if you didn't actually want to find the first occurrence, but you wanted to start searching from a particular index? For example, we could use the find next function, but we pass in a third argument, which is where we are going to start from. So what find next does is it says find the next occurrence of this character after this index. So we would start from index 6 and then look for the next occurrence of A. After index 6, the next occurrence is 10. But had it been we started from index 5, so if we tell it start searching from index 5, it will quickly just choose that because index 5 is A. You can also use the find previous function. So like find next, what find previous does is it starts from a particular index and looks for the previous occurrence of that character. So I am starting from index 13 and looking for the previous occurrence of character E. We have occurs in. So occurs in gets a string and checks if this string occurs in the word. We can check and find out that Julia is present in the string Julia is awesome. What of Java? Does Java occur in the word Julia is awesome? No, that is why it will return false. So it's pretty straightforward. Does this set of string occur in this string? What of Jul? Does it occur? Yes, it occurs because we can see Jul. But if I say July, is there any sequence of characters in that word that forms July? No, so we see false. What of some? Yes, actually, there is a sequence of characters that form some in the awesome word. So it returns true. So that is what you can do. You can check for an index or check if a string occurs in another string. The beauty of Julia. Julia is awesome. Let us talk about some string operations we can perform. The first function we're going to look at is length. Length simply returns the length of a string. If I call length and pass in a string, it returns the length. So for example, if we run this program, we see 16 because the word Julia is awesome, the sentence is made up of 16 characters. If I just use Julia, we have 5 characters. Now, what if I want to generate a string from this particular word, but repeat the word a certain number of times? I can use the repeat function. So in the repeat function, you pass in the string you want to repeat, and the second argument is how many times do I want to repeat this. It returns a string with that particular word repeated in the amount of time you specified. So ln is a string that has Julia 10 times, as you can see in the output. You might need this sometime in the future, who knows? It is good to know what it does. We have the join function. So what join does is, it accepts an array of strings. The second argument is a delimiter. Then the last argument is going to be used as the last delimiter. So we see Java, Julia, and Python. We could also see Java, Julia, Kotlin, and Python. We also have some regular expression. Now, we can use the match. What match does is, it searches for the first match of this regular expression in the string. It will search the string, which is the second argument, and look for the sequence of characters that match this regular expression. Now we can call match, which will return the substring that matches that regular expression. So the substring that matches it is Julia. You can read more on the regular expression. If you read about Perl regular expression, it's similar to Julia's regular expression, so you can read on that. Now, if we scatter the string and we run it on the regular expression, The first substring that matches it is Java. Now, remember string interpolation. We could do this, like if I print this program, it will say hello 10. But what if I wanted to print hello $10? 10 isn't a variable name, so there might be an issue because it might look for a variable called 10, so you have an error. If you want strings to be printed out raw, all you need to print out or add is raw in front of the string. So Julia sees it as a raw string, no strings attached. Take that joke. The string is just printed out raw. So you can go and read more about strings and the fun operations you can perform. Let us talk about functions in Julia. Now, the Julia documentation defines function as an object that maps a tuple of argument values to a return value. Now, in simple terms, this is simply a function like you have in other languages that accepts arguments and returns a value after probably working with those arguments. I have created a function here called work. To create a function, you write function, then the name of the function, then you have your parentheses. You can specify the parameter. The parameter name here is x, and I am returning x times 2. The last element or the single expression in the method is automatically returned. I don't need to say return x times 2. To call the function, I will simply call it, put the parenthesis and pass in the argument. What I did there was to quickly print out the returned value. And since I passed in 10, 20 was returned. We can have multiple parameters. For example, I can have x, y. And I can perform mathematical operations. I could say the new value of x is x plus y, and then return x times 2. When I pass in 10 and 2, the new value of x will be 12, and it will return 12 times 2, which is 24. And that is why we have 24. You could use the return keyword. Nothing stops you from using it. And generally, you might need it in special cases. For example, let's say we haven't done if statements, but let's say you have an if statement, and if you want to return a value depending on the condition, you could use return. You could simplify the function by using this one-line expression. This is useful if the only code in the function is just an expression. This is a simple way. What this says is this function returns x times y. You can pass a function around like a value. For example, if I say person is equal to work, notice that I didn't put the parenthesis around work. So I am actually saying assign work to person. The variable person now behaves like the function work. So I can now call person and pass in 2 arguments, and it will return x times y. In this case, 2 times 3. So that's the beauty of functions. You could have a full function, a simple inline function, and you can pass functions around like values. Let us talk about the return types of functions in Julia. So if I tell a function to only return int, If I attempt returning a string, I will have an error. This is useful in situations when you don't want a function to just return any type of data. The return type is normally stated after the parentheses. We have a function here called sumNum. It simply accepts 2 arguments and prints out the sum of these arguments. We can call the function and pass in 3 and 4. When we run it, I think as usual, we should expect 7. What if I assign the return type of this function to a variable and attempt printing this variable? We will see 7 and nothing. Now in Julia, when a function doesn't have a return type or doesn't return anything, it returns nothing. Now, the term nothing is a singleton instance of a type called nothing. We can make the function compact. Like I said before, if you have just one expression, you could use the compact way of creating a function, but this still returns nothing. However, if it was a plus b we returned, that means we want to simply print out the return value from sum. Sum will return 3 plus 4. We will save that value in x, and then we would print the value of x, which is 7. We have been dealing with functions without return types. We can specify them with a double colon. Now, for this function, we are telling it to only return type string. However, based on what we are going to do, we are going to pass in 2 int values. So we pass in 2 numbers. This will likely cause an error because the function only is supposed to return a string, yet we are trying to return a plus b. So when we run the program, we see an error, just as we expected. To make this work, we can convert this equation of a plus b into a string. We can save it into a variable and then convert it into a string by using the string function. This will convert the variable ans to string, and everyone is satisfied. You can make the return type of a particular type of integer. For example, if I want it to be int 16, I can change it to int 16. This way, I don't even need to convert it to a string. You can verify the type of a variable by using type of. So if I print type of x, you can see x is of type int 16. We can still specify the return type even if we are using the simplified way of creating methods. So this simply returns a plus b. We can specify the return type to be a string. In that case, we need to convert the return type to a string if the original return type isn't a string. This will print out a string. It prints out string because x is a string. Now, by default, a function returns nothing if it returns nothing. We can make this function sumNum to return a times 2, which is fine. However, what if we tell this function to actually return nothing? When we run it, we see an error. We can remove the expression that is to be returned so that this function returns nothing. Because it returns nothing at this moment, it is satisfied. I hope you have learned how to specify the return type of a function and even use it when you're using the simplified way of creating a function in Julia. I mentioned before that functions can be passed around like objects. Let us create a function. We will use the assignment form, which makes it simple and able to create in one line. This is a function named SumNum that returns the sum of A plus B. Now, if you notice, when we are using the assignment form, we don't need to say function in front of the function name. Just a tip in case you noticed that. Now, when we print out the return value of this, it prints out 10. Now, this is because we are storing the return value of a call to SumNum in result. However, if we assign SumNum to X, we are assigning the properties, the behavior of this function to X. Now, X is a callable. We can now call X and pass in values, and it will behave just like the SumNum function. Now, this is passing from object to object. You can also pass in a function as an argument to another function. So let's create a function called toNums that accepts 3 arguments. Now, we want the first argument to be a callable, or in other words, a function that accepts 2 values. When we are calling this function toNums, the first argument will be a function. We will store the results of the function return value in a variable called result and then print out result. When we call toNums, our first argument has to be a function. We already have a function called SumNum, so we will pass it in. Then the remaining 2 values can be numbers. When we run this, it prints out 7. What happened was we passed in SumNum. So SumNum in the function is represented as OP. So we called it and then we passed in 2 values. The 2 values X and Y. Now, the beauty about this is you could have different functions. Like example, I have PowerNum that returns A raised to power B. I can come to toNums and quickly change the method it uses to PowerNum. So this will return 3 raised to power 2, which is 9. There are some things you should take note of. If I pass in 10 as the first argument, I will have an error because 10 isn't a callable. You can't call 10 as a function. So whoever you pass in as the first argument should be a callable object, which is like a function. Another thing, if PowerNum accepted only 1 argument, you will have an error because the function toNums sees OP as a function that accepts 2 arguments. The function you pass in should correspond to the function required. Also, when you're passing in the function, you should avoid using parentheses. All you need to do is just to pass in the name. So aside from passing functions as objects to variables, you can also pass it to another function as an argument. In Julia, operators also behave like functions. Not all operators behave like functions, but popular ones like addition and multiplication. We have a simple sum operation here where I added 3 numbers. I could use the plus sign as a function and pass in those numbers as parameters. Let me demonstrate what I am explaining. I call the function. In this situation, the function name is the symbol of the operator. And then you pass in the arguments. And the nature of that operator is applied to the arguments. In this example, addition. So we can run it and we see the addition printed out. You can pass in a variable length of arguments, so it mustn't be 3 numbers. Let us change the operator to the multiplication symbol. This will multiply the arguments. So I could assign a variable to an operator. Now that variable will behave like the operator, and now I can call the variable, which is now a function, and pass in the arguments to that function. So this particular function multiplies all the arguments. So keep in mind that in Julia, some operators behave like functions, and you can pass them around, just like other functions.